Thank you so much for having me. I'm very excited to be talking about this amazing project that I've been working with the IRS on releasing or expanding access to administrative tax data. But before I begin, I'm going to first say exactly what Urban Institute is, because I realized when I was talking to everyone here, many of you do not know. We're a nonprofit public policy research institution, and we elevate the debate on social and economic public policy issues. So this is why we are trying to figure out ways to better access this very sensitive and important data set for public policy decision making. And of course, before I go into any further in my talk, I have to thank these amazing funders, the Arnold Ventures, NSF, and CSES, which is the National Center for Science and Engineering Statistics, and the Alfred P. Salone Foundation. And of course, because for the sake of time and nobody wants to see all the names, there's over 20 people who are part of this project and over 38 people who are part of the advisory board, so who help inform us on things that we need to think about, some of the challenges and so on and so forth, which many of them are actually present here and also on the Zoom call. So thank you, all of you, for contributing to this very important work. So, but given the time constraints, I'm just going to give a very high-level motivation and project overview, and then specifically going into the more of the statistics of the project, especially because this is the Statistical Methodologies section. So I'm going to dive in deeper into that part of the validation server. But please note that this is a massive project with a lot of pieces to it, and so I'm just focusing on one of those pieces. And then talking about some of the challenges and future work, and some of it is kind of like a call to arms for our field, because there are some challenges that I would really like our field to try to address. So the motivation here. So in public policy, a lot of us are really focused on this executive order from Joe Biden, because on his first day in office, he made this EO on about, or when I say EO, that means executive order, on advancing equity for all, including people of color and those who have been historically underserved and marginalized. So this means we need to have access to finer grained demographic data, but we obviously understand the whole part of this workshop is that there's a tension between getting access to that information and also privacy. And so we kind of have this general framework, and I like to give this figure for people to show that we have to all work together on figuring out how we can take the analyses that the users want, work with the privacy experts and those who have the data in order to figure out well, what are the statistics or information we should highlight when we release those summary tables, statistics, and public micro data. And so when you see SDC, I mean statistical disclosure control, because in the field we call it SDC, or statistical disclosure limitation. So just kind of clarifying some of the acronyms, because I feel like I have to do that, especially from DC. Everything's alphabet soup there. So if I see any acronyms and do not clarify, please let me know. So this framework has been working for quite a while. Either you get direct access to the confidential data after going through clearance, or you get the information through these summary tables or micro level data. However, why are we working at an institute to figure out other ways to access data? What has changed? Well, one is that the increase of data and computing power around us have significantly made it easier in the last decade, to be frank, to identify people. So just put this in perspective for some people, smartphones didn't really become prevalent until about the last 5 years. I say 5 years, but I'm now skewing my timeline because of the pandemic here. But so think about 2010, smartphones weren't as prevalent then. Social media was just kind of starting. But now think about where we are now, where social media is everywhere. We all have small little computers in our pockets that are more powerful than the desktops we had back in 2010. So that is becoming more of an issue and has been raised concerns for the IRS. Also, the fact that they are these different measures of privacy risk and protecting against them is evolving quite rapidly. And so that's something else to concern. But I think most importantly on the last bullet here that I have is that survey response rates have been an all-time low. And so this threatens that fact that getting access to that important information gets a lot of researchers jittery, and they're how am I going to do my research? How am I going to access this data? So maybe I have to look into accessing administrative data. And in that case, there's more restrictions on to access it. And so this is why we are looking into how can we get researchers access to that valuable data. So going into this project overview here, where we're proposing a tiered access system. So I already talked about the first tier, which is getting release of the summary tables or getting some micro data sets. So in our case, we're looking at different synthetic data methodologies in order to get that information out. I talked about the full access is what we called. So that's going through the lengthy clearance process so you can see the confidential data and run your analyses. But to be clear, though, even if you have access to that data, it still has to get reviewed, like any results you have, through a disclosure review board, typically in the federal statistical agencies. So that still has that little caveat there. Also, the fact that, just as a side note, I've gone through 4 different clearances for 4 different agencies. It never gets easier. So it takes a very long time, and also a lot of these data sets, you have to be a U.S. citizen, which eliminates a lot of researchers here in the United States. So we need to look at better ways. So this is why in our project we are focused on the first 2 tiers, but in this talk I'm going to be focusing on what I call a validation server, because we're trying to figure out, is there something in between these 2 extremes of getting access to this micro data level data set and getting access to the confidential data set. So some of you might be wondering, what is a validation server? So I want to clarify what I mean by a validation server before I move on. So the difference between a validation server and a verification server, because even in the privacy field, there is like a fine difference between the 2. So a verification server provides information about the quality of the statistical inference you want to do. So if I were to run a regression analysis on a public data set and I want to confirm that certain coefficients are significant or if they have the same sign, then I would submit my analyses to the verification server and get a yes or no answer back, saying like, yes, they are both significant. No, they are not. Versus a validation server, and in particular, we're looking into automating it, where after you kind of debug or test your analysis, like your code on the synthetic data or the public data set, then you submit it through a validation server, and from there, the validation server applies that analysis to the confidential data, and then before getting results back, automatically adds this privacy-preserving or some sort of noise on top of it before you get your answer back. And that's what we mean by a validation server, and to provide full inference on it. And I'm emphasizing full inference because that's going to be a hot topic that I'll be talking about in a little bit in my talk. So in particular, again, I said this project is very massive. We are looking at the infrastructure. How do we do the UI? How do we do the back end? Things like that. But this part of my talk, because this is a statistical methodologies session, I'm going to talk about our feasibility study. So it's funny that initially when we proposed to look into how we develop validation server, we called it a comparative study. But we realized as we were working on it that it's a feasibility study. So we were looking at all the different formally private methodologies and seeing how would they perform if we put them into a validation server framework, and would it actually work for the tax economists if they were to analyze this data. And so we conducted it on looking at tabular statistics, means and quantiles, and regression analyses. We picked these ones in particular because after doing some informal interviews with some other tax economists, this was the first baseline of, they said, this is what we need bare minimum. If we cannot do this, then there are going to be some issues. We also tested on 2 different data sets. One of the data sets is when you see I realize there's an SOI there. That's Statistics of Income Division. It's a division within the IRS. They have a public use file, which is based on taxpayer data. That one is a little bit more restrictive, and so that can't be publicly available. So we tested on this data set, but we wanted to have a public data set because we want to stress the importance of open source code and being able to be open with our results. So this is why we also looked at the 2020 Current Population Survey Annual Social and Economic Supplement data set. And again, we tested all these analyses, and then note that some of the methods that work in theory with specific conditions and have issues working in practice. So this is why we are calling it, again, emphasizing, is a feasibility study. Are these methods feasible in our framework? So going along with this feasibility study, we wanted to make sure that whatever kind of like quote-unquote analyses maybe a tax economist would conduct, we looked at what would be some of them they would do. We looked at some of the papers. Some of them were more recent as of 2020. There was a couple that were a little older, but they were still viable. And so we were looking at like, well, how many tax returns have a salary and wage income in excess of 100,000? So that's a single count. All the way down to the regression, what is the effect of first dollar marginal tax rates on the realization of capital gains, and what are strong indicators of wage and salary income for gender? So these kind of analyses are ones that we saw in literature and we're testing on the data sets. So I'm going to skip over tabular statistics because that's done and over with, and we already see that it does really well. So we're going to focus on the means, quantile statistics, and regression. So when we were looking at different quantiles and means and emphasizing the associate standard errors because we wanted to give confidence intervals for our users. These are the methods that we ended up excluding because we actually had to eliminate a lot of methods because they required the user to set prior bounds on the data or on the inference they wanted to do. And so that's like, nah, that's not good because most of them can't actually see the data, right? They only have the synthetic data, so that's not realistic. Some of them were highly sensitive to assumptions. So for instance, there was one method that assumed that the mean and median were both the same. And we can't have that either, especially with some tax variables that are highly skewed. So we eliminated those. And finally, some of them just did not produce confidence intervals, which is not a viable option either. So again, I'm emphasizing this because that eliminated, I think, roughly half of the methods that we were considering. Going on to the regression analyses, we did the same thing. We had to check whether or not it would seem like realistic assumptions that could apply to the data. Some of the ones that we did also eliminate only applied to single predictors instead of multiple because in all reality, like most social scientists and tax economists want to look at interactions, multiple terms at the same time. And again, we had issues of finding ones with full inference. Now, I will say that we were not looking at any Bayesian methods. We were looking at frequentists for now. So that's one of our future works is also incorporating some Bayesian methodologies. Now, going into the results, this is just a high-level overview. I'm just doing some bullet points here because, again, I just wanted to emphasize some of the different things that we did. Also because we produced a lot of plots. This is why we have a GitHub repo. It was because there was a lot of results because we had to look at a wide range of values for the privacy loss budget, so epsilon. We looked at 3 levels of delta. We looked at bias, root mean square error, confidence overlap value, which for those who are not familiar with what confidence overlap value is looking at the confidence interval from the original or confidential data set and seeing how much it overlaps with the altered data set's confidence value. So if they don't overlap at all, you get a 0. If they overlap some, you get a certain, well, if they perfectly overlap, it's a 1, and I'm probably botching this right now. But that's very unlikely that it'll be perfectly matching. So it's just looking at how much do those, again, the confidence intervals from the confidential data and the released noisy data overlap. So that's just a quick overview on that one. So on the tabular and summary statistics, we realized the results did pretty well after epsilon was at least 1. So that's good. But when we move over to regression analyses, it wasn't as good. And you might be wondering, like, why do you have a bootstrap size of 10 and 25 here as part of your testing? I will talk about that in a moment. But anyways, this is what we had to do in order to get some confidence intervals later on. So in addition to looking at bias, root mean square error, confidence overlap, we also looked at confidence interval ratio because we realized that just looking at overlap value wasn't going to be sufficient. And we're also looking at coefficient sign match because, frankly, you want to make sure that the signs are the same, right? If they're not, then that, like bare minimum, that's not good for the tax economists doing the analysis. And also looking at significance match. And just as like the punchline here is even for very large values of epsilon, which we tested all the way to 20, the methods definitely still need improvement. The results were not as good as we would like. And so some of you might be thinking, okay, Claire, I really want to see some plots here. But again, for the sake of time and trying to get to my call to arms part of this talk, I encourage you to look at our code and results that are on GitHub. So you can, there are in the framework of what we call R Markdown pages. So you can just scroll through and it's really easy to look through them all. So you're like, okay, Claire, you mentioned this bootstrap. You said that things were not as great. Like, what do you mean by that? So we had kind of 2-prong of like issues or challenges throughout this feasibility study. First off, it was the methodology. So like I said, the differentially private methods worked really well for simple statistics, but really struggled to produce accurate regression estimates and confidence intervals. And when I say that, when looking just like at the sign match, the rate of which that we got the correct sign match wasn't that good. It was like 50% or less than 50% until we got up to like, I believe, epsilon of 10. So that's why we're saying like, well, the bare minimum, we need to have that. You need to have the right sign. So that was a little disappointing. And also, there was only actually one differentially private regression method that satisfied our inclusion criteria. And actually, it was Dan's paper. So good job, Dan. So it was actually your method that satisfied our criteria. And we actually took some of that methodology of the bootstrapping those intervals to apply it to other methods to make them satisfy the whole we need the confidence intervals. So we expanded from having only one regression method to test to 6. So again, I encourage you to look at the paper and our results to see like how we actually did that. Now going into the other challenges, which is like coding implementation. So I'm stressing this because if we want to have others adopt our methodology and be like more widespread and kind of have this like more collaborative environment with other researchers, we really do need to make it easy for them to implement our methodology. And so when we were looking through all these different methods, we found some issues with the coding implementation. So the first off was we did run into errors in both the GitHub code and also the pseudocode. So sometimes even the line-by-line explanation of the algorithm didn't quite work out. And I mean, that was still good. At least we had code, at least we could talk to the authors and try to correct some things. One of the other issues is like some of the code was applied to a particular application and not generalized, which that's, again, it's still a minor thing because you're not expecting researchers to produce like product ready code, right? But at the same time, it would be nice if they could generalize it a little bit so that way you could kind of pick it up and apply it to something else with some like light modifications. But at the end of the day, we did have to eliminate a lot of other methods because sometimes the code wasn't available. There wasn't enough details in the paper. And so when we reached out to the authors saying, hey, can you clarify on some things, they didn't respond. So that was an automatic elimination. For instance, there was one paper that had an extra tuning parameter, and we explored into it and said, like, well, how do we actually set this tuning parameter? And we asked the author, and nothing. So we had to eliminate that because we can't expect the user to figure out what that tuning parameter is on top of epsilon and delta, so it doesn't work. So to wrap up this talk, so some of the future work that we're looking into is, well, this one is really interesting, especially with this audience, like how should we assess the noisy results in a way that's realistic and interpretable for non-privacy experts? So I just was briefly talking about this with somebody earlier, is that well, it's great that we did bias or relative bias and standard error and confidence interval overlap, but most people are like probably will give you a look of like, what are you talking about? Wouldn't it be better to try to tell them like, well, are the original confidence interval above or below what you're given? Is it within the confidence interval? Is the coefficient significant? Is it not significant? And of course, did the sign flip? Because that's going to be really important and it will impact public policy decisions. The next one is like, what are researchers' threshold for noisy results? This is something when we were trying to think of like, what's the next step after doing this feasibility study is maybe we should stress test some of these methods because we already have them all coded up and figure out what is their like quote unquote breaking point for a certain kind of analyses. And so while we were conducting this, we realized like, oh, well, we don't know what that breaking point is. And so actually, maybe some people on Zoom was hearing this, that we submitted a survey to tax economists and to see what is their threshold tolerance between they rather have no access to administrative data because the results are too noisy. So like, what is that point? So that survey is going out right now. So like to be continued this summer to figure out what those results are. And then finally, of course, like what is the education and communication materials are needed for researchers to use this validation server? Because we want to empower them to make the decisions for themselves of what epsilon and delta they would use, how would they spend that budget and use the validation server, and also trying to make sure like how do we also communicate the other nuances of research, such as how do you tell a journal that this result has been kind of altered? And then what if the reviewers say like, hey, you need to rerun your results again? So like, how does that dynamic work with the whole publication scheme or other aspects of academia? So with that, kind of some call to arms to everybody on thinking about inference and how we can move this field forward. So thank you so much for listening to my talk. And here's my information. If you're interested in contacting me, I can provide the link to the paper and also to GitHub if you missed that. Thank you so much.
Thanks, Claire, for a talk with lots of exciting avenues for future research. In interest of time, let's have one question.
Thanks, Claire. I'm wondering about one of your last questions. Would researchers from, say, the Congressional Budget Office or the Joint Committee have a different approach and set of requirements than an academic researcher that's just presenting something or trying to get it published? Have you guys thought through whether there would be that sort of classification on, would there be different tooling perhaps for users that are using it for budget scoring or something?
That's a great question, Amy, and I'm going to step back especially for those who are not familiar with the framework. So this data set from IRS, like the Congressional Budget Office, JCT, Treasury, they get access to the data and they can do whatever they want with it. So when we try to think about like a formal privacy framework, this actually isn't going to be a true one because there are other entities that do access that confidential data and can release whatever summary tables they want. So it's to Amy's point, it's like how do we then balance with the whole education materials and communication with researchers about that, given that you do have, or JCT is Joint Committee Taxation, or I'm totally botching that, as another entity in the federal government system. And so trying to tell other, not just public policy makers, but then researchers to say that like this is not true formally private framework, but at least this is better than what's going on right now, which is very limited access to the data set, or the fact that a lot of it is like the current methodology to release the public use file that Urban, New York Times, Economica, or it's like Associated Economic Analysis and Brookings, and there's a few other entities are the only ones who have access to that data. And even then, it's very aggregated and suppressed. So what we're doing is so I'm just going to say that we're doing better than what's doing now, but we do have to keep in mind on how we do communicate to people about how others do access that data, what can you do with it, and the fact that there is this interplay of the researchers with the journals, also with your entities. I think I answered your question, but I realized I drifted a bit because I got like on my soapbox a little bit, and I'm like, we need to solve a lot of problems, and it's huge, and we're testing things. So I will say that our project, we're going to find more failures than we're going to find solutions, right? Because this hasn't been done before, so which is fine because a lot of documentation said lessons learned. We should not do this because we're testing it. So I think that's like one of the biggest contributions we're doing is saying like, hey, this part doesn't work, so maybe we should look at these things, and then tell you guys to like, maybe you should look into those things, and then hopefully you can. So.